today we are going to be talking about more segment addition, and then we're going to throw in some information about the midpoint as well. All right, so our first one, we've got some segment relationships here, but a little bit more complicated than before. We've got to look at all the pieces here. Now it looks more complicated than it is, so let's just take this one piece at a time. Our first thing we want to do is we want to find QS. So I look at my diagram, here's Q, and I want to go from Q all the way to S. So I want to find the length of this segment. Well, I see that from Q to R is 28, and then from R to S is 27. So to find the length of the whole segment, I want to put those pieces together. And when I'm putting pieces together, I'm going to add. So I'm going to do 28 plus 27 to get this segment length as 55. So the first thing we solve for is QS is equal to 55. Now the second piece that we're looking for is PQ. So I'm looking for PQ. I don't have any direct information the way I did on QS. So I kind of want to look at the relationships among the pieces I see. I'm given this 78. 78 is from here to here. And I'm given that this portion is 28. So I'm given this whole piece and a part of it. So to find PQ, I know it's part of that whole 78. This part is representing the 28. I'm finding the missing smaller piece. So for this one, I want to subtract 78 minus 28 to get the 50. So always think back of, am I putting pieces together? Which means I would add, or am I finding a missing piece of that's going to be smaller? If it's going to be smaller, then I'm going to subtract. All right, next one, solve for x. So we see this symbol here. This is a congruency symbol. A congruency symbol can look pretty much like anything. A lot of times I'll use circles, or I'll use a double line, or I'll use a squiggly. A congruency symbol is just the same symbol showing that your pieces are the same. So this diagram is showing me that the segment AB has the exact same length as the segment BC, which is really important because when you write an equation to solve, that equal sign, equation, equal. To write your equation, you're looking for two values that have the same length. And we're lucky because AB is the same length as BC. They are equal. So I can set AB equal to BC. AB has the same length as BC. I set those two things equal to each other. And then I solve. I have a 10x and a 5x. I'm going to move the smaller one because remember I want to try to keep my variables positive when possible. 10 minus 5 gives us 5x plus 4. 5 minus 5, that's gone, that cancels. We move our 4 over. 5x is equal to 40. 5 times x, so I divide by 5 to get my x equal to 8. So that's the first part, x is equal to 8. Now I want to find what the length of AB is. Well, it's 10x plus 4, and if x is 8, that's 10 times 8 plus 4. That's 80 plus 4, so AB is 84. Done. BC. Now I could do the same thing again. 5 times 8 plus 44, 40 plus 44, or I really didn't have to do any work at all because we said from the beginning, what do we know about those two things? They're equal. They are congruent. So if AB was 8, oops, oh, I can't write and talk at the same time. So if we knew that AB was 84, that meant that BC also had to be 84 because the two segments were the same. All right, our very last one here for example 2 is AC. So AC is the length of the segment starting at A and going all the way to the end of C. So that's going to be segment AB plus segment BC. I have to put those two little segments together to get the big one. So 84 plus 84 is going to make AC equal to 168. Moving on to example 3. So in number 3, it says G is the midpoint. This is a big vocab word that's going to be really important, play a big role throughout the entire school year. The midpoint is the point that bisects or divides a segment into two equal pieces. That's really important. So if G is the midpoint of AB, that means AG is equal to GB. Now sometimes the midpoint comes into play like it did in number 2. It allows us to set two pieces equal to each other to solve. I don't have anything to set it equal to here, but because those are the same, I could make that as x minus 3 because they're the same. Therefore, they can be represented by the same expression. Now that doesn't make sense. X minus 3 equals x minus 3. If I try to do that and I move the x over, well, that's gone. If I move the 3 over, that's 0 equals 0. I canceled everything out. Of course you canceled everything out. They're the same thing. That's not going to work here. To solve this equation, we're using our segment addition. This plus this. So x minus 3 plus x minus 3. These two segments together equal the big segment, 8x minus 21. Now some of you may be thinking, well, it's just 2 of x minus 3's. Yes, so you can either add them twice, or you can take 2x or x minus 3 and multiply by 2. Either way, whether it's two separate pieces or distributing, you end up with 2x minus 6. We move the 2x over, because I like to move the smaller x first. 8 minus 2 is 6x. And then we move that 21 over. Be careful, this is a negative 6 and a positive 21, giving you a positive 15. Then it's 6 times x, so we divide 15 divided by 6. We have options here. When we reduce 15 over 6, it's going to reduce down to 5 halves. So we can say that x equals 5 halves. Or we can say that x equals 2.5. You can write your answer as a fraction or a decimal, because in this case, your decimal is an exact decimal. If it wasn't an exact decimal, you would have to leave it as a fraction. All right, so there is our extension on segment addition. We are done with for today's video.